Now let's take a look on reflection across the y-axis. Okay, we have two graphs, graph C, which is this one, and graph D. Are they a reflection of each other? And if we take a y-axis like a center and imagine that these two graphs are on the y-axis, it actually will be that these two graphs like a mirror reflection of each other. Now let's take a look on table of data of these two graphs and check what's actually happening with the values. Now if we had points -3 here on the C graph, it equals 1/8, -2 corresponds to 1/4, -1 corresponds to 1/2, 0 corresponds to 1, it's our center actually, and 1 corresponds to value of 2, x equals 2 corresponds to value of 4, and 3 should be somewhere here, corresponds to 8. Now let's take a look on graph D, which is at 3 is -1/8, at 2 is 1/4, no, it's +1/8, sorry. At 1 it equals 1/2, at 0 it equals to 1, at -1 it equals to 2, at -2 it equals 4, and so on. Okay, now what's actually happening to our values? If we check that our y values are exactly the same, but what's happening, it's actually our input or x value has everywhere a different sign. If it was negative, it's positive on graph D. If it's positive on graph C, it's negative. And it has the same value as if we take absolute value 2, but the sign is different. It means to do our reflection, what we have to do, it's actually to change the sign. If our value was like let's take here 4 of our function, and corresponding value of x was 2, now this, to reflect it, we're actually taking it will be -2x, x equals -2, and function value again equals to 4. Now if our graphs will be a function 2 to the power of x, what will be our new function? Or this one, how we can represent it? How we did from the table, we just did our input, just negative input. It means if it was 2 to the x, now it will be 2 to the negative x. Or if we represent it in this form, like y equals f of x, our reflection will be just y equals f of negative input, just negative x. And that's it, what we have to do, just change the sign in front of an input, and that's it.